Kia ora koutou, everyone, and a warm welcome to this July Brown Bag Resilience Series webinar. I'm Jeff O'Malley from Tautu Te Whenua, Land Information New Zealand. I'm Principal Advisor, Geospatial Capability Building. And these short webinars that we're running, for those interested in improving the resilience of New Zealand and New Zealanders, and they're hosted by Tautu Te Whenua, LINZ, and the Ministry of Transport, Te Manatu Waka. So during the webinar, if you've got any questions, put them in the chat window and we'll have time at the end for some answers. And also the webinar is being recorded for those who couldn't make it today. So the topic of today's webinar is property insurance and climate change risk in New Zealand related to extreme precipitation-induced floods and landslides. And it is a very topical topic given the extreme precipitation-induced flooding that we've had recently in New Zealand and Canterbury and the West Coast and Marlborough. And today's speaker is Jacob Pastapaz, who's a natural hazards risk modeler at GNS Science. So a bit of background about Jacob. So he's an economist and also a cartographer, geomatician by training. And congratulations to Jacob, because early in June he defended his Victoria University PhD on the topic of this webinar. But before he did his PhD, he's got a varied history in terms of roles. So he worked as a research analyst of seismic risk, remote sensing and cartography at the National Institute of Geography of Ecuador. And other professional experiences include research analyst positions at QuakeCore NZ Centre for earthquake resilience and the Inter-American Development Bank, the National Institute of Statistics of Ecuador, and stints at the National Institutes of Statistics of Uruguay and Peru as a consultant for the OECD, the Organisation for Economic Cooperation and Development. So welcome, Jacob, and over to you.
Thank you very much, Geoff. Tēnā koutou katoa. Thank you for having me today and giving me the opportunity to present my research. As Geoff mentioned it, I'm a risk modeler with a background in economics and GIS and remote sensing. So today I'm going to talk about one of the chapters of my PhD, where I investigate the effects of extreme precipitation and climate change on direct residential property damage that is associated with rainfall-induced landslides, storms, and floods. This chapter is the result of collaborative work with Professor Illinois, Isabel Sin, Abba Sood, David Fleming, and Sally Owen. Next slide, please. So this research is motivated by the fact that in Aotearoa, New Zealand, property damage from weather-related hazards such as floods, rainfall-induced landslides, and storms are covered by the EQC, which stands for the Earthquake Commission. The problem here is that the effect of climate change is likely to translate into higher property damages, and thus an additional liability, potential additional liability for the public insurer. And this is of great importance for the EQC, as it needs to know or to have an estimate of what these liabilities will be for different purposes, but mainly to assess its financial sustainability and its ability to access reinsurance in the international markets. Ultimately, the financial health of the EQC will ensure that homeowners can recover from the impact of natural hazards. Next slide, please. Therefore, in this research, I address the following research question. What are the EQC's expected future liabilities given future climate projections? Next slide, please. So I find that liabilities from property damage associated with extreme precipitation as a result of climate change vary. That means that they increase or decrease over time and space. However, at the aggregate level, we see that the percent change between past and future liabilities ranges between an increase of 7 to 8% higher in the next 20 years and an increase between 9 to 25% increase by the end of the century. And that depends on the greenhouse gases emissions scenario. I also find that exposure plays an important role in the level of observed property damages. We find, for instance, that locations with damages are closer to the shoreline and waterways, like rivers, are within flood-prone areas and lower elevations, and have higher number and value of residential assets than locations without damages. Next slide, please. I will just briefly cover what is the nature of the insurance scheme provided by the EQC. So we've got a basic understanding of what includes or what it does not include. So the insurance cover is building, land, and contents damage that are the result of rainfall-induced landslides. But there is only cover for land damage that results from floods and storms. When it comes to the insurance cover caps, the building caps is set up at 100,000, contents cap at 20,000, and the land cap is the value of the land. I need to make a clarification here. These are the caps related to the previous insurance scheme, because recently, I think it's 2019, that these caps were updated. So for the building would be 150, contents caps is removed. Okay. And finally, the private insurer will cover anything remaining above the value of the cap. Next slide, please. This picture just shows an illustration of what is covered. So when we're talking about buildings, we're talking about the dwelling as well as the appurtenant structures. And when we talk about appurtenant structures, we refer to either a storage room, garages, etc. And when we're talking about the land cover, this is something important to have in mind, because it's not only the land underneath the building, but it's also the land that is located within an 8-meter buffer of the buildings. And also the land cover would include damage to retention wall, access pathways, bridges, and some other details. Next slide, please. Now I'm going to jump to the methodology. And there are 3 big steps that comprise this research paper. And the first step, I modeled the relationship between extreme precipitation and the historical distribution of insurance payouts using a statistical approach known as a regression analysis. Think of it as estimating an average. In the second step, I apply the estimated parameters or the relationship from the step number 1 to future climate changes scenarios to project the value of insurance claims in the future. Finally, I calculate what's known as the climate change signal, which is calculated as the percent changes between past and projected liabilities. So in the following slides, I'm going to cover in detail every step of the methodology. Next slide, please. So for this first step, I use EQC weather-related claim data for all of New Zealand for the period between 2000 and 2017 to estimate the effect of extreme precipitation on insurance payouts. The equation you're seeing here is a regression model equation where you have the outcome variable or the left-hand side variable represented by the letter Y. And that represents the total payouts in New Zealand dollars in grid I and time T. When you think about grid, think about allocation, okay? And then we've got the most important variable in this statistical model, which is extreme rainfall. So in this model, we argue that extreme rainfall is what is driving property damage. And extreme rainfall is defined as the count of the number of extreme precipitation events in a given location in a given year based on the 95th, 98th, and 99th percentile of observed daily precipitation from a time series between 2000 and 2017. So to give you an idea about selecting what extreme rainfall is, imagine a bell curve, a normal curve, and imagine that we're interested just in the tail of the distribution, in the extremes. These are the events that we are interested. Okay. I should mention that the percentile thresholds are defined separately for each location, and only wet days are considered for the calculation. And to account for antecedent conditions, I calculate the same percentile thresholds for up to 5 days of accumulated rain, because we know that damage is not necessarily the result of 1 day of precipitation, but it could be several days of precipitation that lead up to damage. So we also want to evaluate what these antecedent conditions mean when it comes to property damage. As I said, I use a fixed effect regression model, and this particular model allows us to control for unobserved characteristics or heterogeneity that can be unique to each location in terms of exposure and vulnerability. This model does enables to calculate unbiased parameters. Please, let's go to the next slide. So now I'm going to talk about the second part of the methodology. As I said before, I use the parameters from the previous stage to estimate future liabilities for different climate change scenarios. Okay, but what about the future? How do we consider the future? How do we count the number of extreme events in the future? Well, the count of the future number of extreme precipitation events is the number of times that model future rainfall, that is the projections, the data in the future, rainfall exceeds the observed percentile thresholds. Okay, and these are the percentile thresholds are the benchmark against which the effect of climate change is assessed. However, the threshold values of observed precipitation and model simulations of past rainfall data are different. Okay, and that's something that we need to bear in mind if we want to actually get reasonable results. Please, next slide. Because there's differences between the thresholds between past climate model of the data and observed data, I calculate new thresholds from the model data of the past, which is based on a time series between 1986 and 2005 as the benchmark. With this graph, I am just trying to illustrate that there are 6 regional climate models used in this study that have been produced by Whenua, and I'd like to to acknowledge the contribution of Abba Sood and in this project, definitely. So these are the 6 different climate models that we're using, and the different times and greenhouse gases scenarios, which are referred as representative concentration pathways, or RCPs. If we could go to the next slide, please. So this is the final step. We calculate the climate change signal, and to this end, I compare the predicted liabilities using the past model of the climate, that is between 1986 to 2005, with the liabilities based on future climate projections for all RCPs in 20-year time slices, for all percentiles and days of accumulated precipitation, and for all climate models. So there's quite a lot of data. Next slide, please. These are the results from the first step of the methodology. This table presents the parameters from a series of regressions of claim payouts on extreme precipitation. Each coefficient in the table comes from a separate regression. So for instance, from the first row, we interpret that on average, one additional extreme precipitation event in a grid cell in a location is associated with 319 New Zealand dollars increase in payouts, where an extreme event is defined as rainfall above the 95th percentile for 1 day of accumulated precipitation. And these results are statistically significant at the 1% level. So what we say is that there is a positive impact of extreme precipitation on insurance payouts. Another way to put it is that for any given year, an additional extreme rainfall event in any location, the expectation is a cost of $319. Next slide, please. This table just shows the predicted liabilities for 20-year aggregates for the 99th percentile and 1 day of accumulated precipitation for all RCPs and climate models. Next slide, please. So this map shows the spatial distribution of the climate change signal average over various climate models at grid level for 1 day of accumulated precipitation based on the 99th percentile. We can see that northernmost areas of New Zealand will have less liabilities, and southernmost areas will experience the highest levels of liabilities for RCP 8.5 in the period between 2080 and 2100. This graph shows the climate change signal at the aggregate level, and it's the result of averaging all the climate models across all the grids of New Zealand. And what we see here is that liabilities will increase more if future greenhouse gases emissions are higher. That means higher RCPs, as you can read along the x-axis of this graph. As expected, the differences between RCP scenarios are more pronounced later in the century, as represented by the red bar, than they are in the near future, as shown in the blue bar. Furthermore, I note that the time profile of the highest emissions, RCP 8.5, is much steeper, with the liabilities more than doubling between 2020 to 2040 and 2080 to 2100. So I conclude that indeed, climate change will increase future liabilities of the public insurer of New Zealand. At the aggregate level, we see that there's an increase between 9% and 25% higher by the end of the century, depending on the RCPS scenario, which is in line with the international literature. A word of caveat: the projections assume constant exposure and vulnerability over time. Therefore, the changes in future liabilities are driven exclusively by changes in hazard due to climate change, given current conditions. And another limitation of the study is that the definition of what an extreme event is based on a short time series. So in the third chapter of my dissertation, I address this problem and I estimate the current and future risk of rainfall, extreme rainfall for a range of return periods and climate scenarios. And when it comes to future research direction, I think it's important to address the implications of the interactions between geological and climate change induced hazards on the financial sustainability of the public insurer. And this is because we know that land subsidence or land sinking as a result of earthquakes can change, for instance, the risk profile by making properties more likely to experience flooding, which changes EQC's financial exposure to weather-related hazards, and climate change might exacerbate EQC's exposure. In addition to that, any change in the private insurance sector will have implications for the EQC. Evidence suggests that increased risk will prompt private insurers to stop offering insurance in high-risk locations. And as a result, the EQC might step in to fill this gap, and its financial exposure and financial sustainability might be compromised. So next, and I think that's it. We go to the next slide, please. To the next slide again, please. And that's the paper, the research paper, the citation, if you'd like to have more insights into what is it that we've done. And those are just my contact details in case you would like to reach out. Awesome, thanks.
Yeah, thanks a lot, Jacob. A lot of time and effort gone into your research. So if you've got any questions, put them in the chat window and you've got an opportunity to ask. Here we go. Andrew's got something. Did you consider depth, duration, intensity, for example, storm durations, past and future? Would also be interested in a copy of your paper. Can you share a link? For example, I'm keen to understand a bit more about exposure modelling.
Sorry, is there any way I can read the question, or can you read it out for me, please?
Yeah, I can read it out
duration,
again.
intensity.
Yeah. Did you consider depth, duration, intensity, for example, storm durations, past and future? Would also be interested in a copy of your paper. Can you share a link? For example, I'm keen to understand a bit more about exposure modelling.
Awesome. Thank you very much, Andrew, for that question. I did not, and actually that's something that I do in my third paper, where I actually consider depth, duration, and intensity for different under different climate change scenarios. So that's something I am working on and would be happy to share. And when it comes to exposure modeling, as I said, this paper does not assumes constant exposure, but that's a project that I'm currently working on. I just started last week about exposure modeling here within GNS, and I'll be happy to also share the results of that as we make progress.
Right. Here's a question from Koyen. Great presentation, Jacob. I'm wondering if insurance claim data is at property level or at aggregated grid level.
Awesome. Thanks for that question, Koyen. We have access to claim level data, but for this paper in particular, we aggregated the data at grid level because that's the level at which precipitation data and projections is produced. But in two other chapters of my presentation, I do work with claim level data.
So what is the just a question from me, Jacob? What's the grid level? Is there a you know, what size is it, for instance? You know, do you?
Sure, that's a 5 by 5 kilometer grid, and that comes from the VCSN, which stands for the Virtual Climate Station Network. So that's a gridded surface that NIWA produces. That's for this paper, but then there's another gridded surfaces that I also use for my other papers, which comes again from NIWA, from the high intensity rainfall design system, which has a 2 by 2 kilometer grid.
Okay, here's another question coming up. What are the potential effects of intensification of housing on exposure to climate change?
Oh, thanks for that question. I didn't present a slide of different grids with different levels of exposure. You would see that the concentration of the damages is quite clear. And as I said in the introduction, most of the observed damages occur in locations that have more properties and the properties have higher value. So I believe that climate change will just exacerbate what is already happening. We've seen in New Zealand. So exposure seems to be a big deal when it comes to the observed damages for the last 20 years.
Okay, question from Kenny. Nice work, Jacob. How much do you think it would matter if you modelled heterogeneity of the impact of precipitation by exposure? That is, have a different precipitation response for areas close to rivers?
Thanks, Kenny, for that question. I'm trying to parse it.
You can't. You want to have a think and come back to it?
Probably I will do that before yep. Thanks for that question. I will make sure I come back to you, Kenny. Thank you.
Yeah. Or maybe, Kenny, if you want to clarify it a little bit or anything, would that help, Jacob? Or?
I'm not sure if that's related because I don't know if this will answer your question, Kenny. We defined the percentile thresholds independently for each grid location because different locations will have different levels of response to extreme rainfall. So yeah, I don't know if that's clearly related to your question, but I'll think about it and we'll come back to you.
I've just got a I said we can chat after, so yeah, that's fine. Question from Tim. Given that EQC does not cover residential property damage from climate change, but only damage to land within 8 metres of the residential property, would you expect the implications of loss to physical property, not land damage, to vary from your findings? Getting some curly
I
ones.
understand. I understand that insurers will not cover for climate change, but I think that's kind of tricky because making event attribution as something underway. I understand that here in New Zealand, there's several studies that are developing studies where they make attribution for a particular event, how much of that event can be attributed to anthropogenic induced climate change. But when it comes to the EQC, I don't know what's the policy. It's the public insurer, so I'm not sure if that they might be able to step away from covering damages that could be or are attributed to climate change, and I'm not sure if that's socially desirable either. So I think this is more like a policy question, and which has important political implications as well. So I'm not completely sure.
Just a quick question from me then. I know your research is pretty recent, but have you had any feedback from EQC in terms of your findings of your research to date?
Not really. I presented part of this work as it was being developed to one of the EQC staff members during a disastrous doctorates event, but I just finished my PhD, so I really haven't had the chance to present these findings to the EQC. But now that I'm working in GNS, we work really closely with when it comes to risk modeling. So hopefully we'll be able to share these results with EQC.
Here's a question from Dwayne. Is or will this resulting spatial grid data be accessible for public to access or use?
Whoa. Thanks, Dwayne. That's a really good question. I understand because this project took place in the context of a research of the Deep South Science Challenge program, and we were given access to lots and lots of data. So I really don't understand. I really don't know if the grid is available, but I do understand that information from individual meteorological stations is available through a platform application known as CLIFO. But the interpolated data from these individual stations that becomes a continuous gridded surface is something that I'm not sure if NIWA provides freely. So I'm not sure about that. Thanks, Dwayne.
Okay, your research depended on quite a few data sets. Is there any key data set or data sets that you would want for future research to be better in terms of resolution or that sort of thing? Just one or two?
Yeah, absolutely. I think that's related to exposure data. It's important to understand the evolution of exposure over time. And I think that's something that could be achievable using satellite or aerial photography. I think that's something that that would give us a better perspective on the evolution of exposure. It's not just the number of buildings affected or residential property affected, but that related to the number of buildings exposed throughout space and time. So I think exposure data is something that would be really important, and not only historical data, but also try to come up with projections as to what that might be. I think that would be really useful. But aside from that, I think here in New Zealand, we're very lucky to have lots of data.
Great. Okay. We've done with the questions, and we're running out of time. So thanks very much, Jacob, for what I said was a very, very topical and also very informative presentation. So if anyone wants to get in touch with Jacob with any follow-up questions, his email is on the last slide there, and we'll record this, and when we put it up, that's another way that you can get access to that. So thanks very much also, everyone, for your attendance, and keep an eye out for the next Brown Bag Resilience series webinar. So, haere rā, and bye for now.
Thank you.